Bismillah ar-Rahman ar-Rahim. Assalamu alaikum, how are you, my friends? This is the first lecture for process augmentation in semester 421. The course code is EEE332. Now, for the first lecture, we prefer to review some physical concepts. We already know them, but just to review quickly in order to help us in the coming lectures. Let's start our first terminologies. Length. We know, all of us, that the meaning of length, we can describe it as the shortest distance between 2 points. It is occupancy of one dimension space. Like example, 1 meter. If we say 1 meter, it means a length, unit of length. Area is occupancy of 2 dimensions in the space. The first one, which is the length, is scale, 1 dimension. The other, which is the area, is 2 dimension occupancy in the space. As example, if we say 2 meters square, that means area, units, length and width. So you can here talk about here some flat surface or volume. It is a occupancy of 3 dimension in space, like a cup of water, like what we are here now in our existence life. We are living in 3 dimension. As example, if I say 2 meter cubic, that means a volume unit is 2 meter to the power 3. The width, calculation in width and length and height, or you can say azimuth, longitude and altitude in other descriptions. Right, now we go to the distance definitions. Distance, simply, it is how far between 2 points or 2 locations. Simple. It is a scalar amount, but if we add a direction to this magnitude of this value, it will give us a new terminology. We call it displacement. As example, if we say 1 meter distance, but without mention the direction, just we'll talk here about distance. But if I mention it as 1 meter and I give also the direction 1 meter to the right, mean a displacement has done with a magnitude equal to 1 meters and the direction to the right side. I can express this displacement mathematically as absolute value and 1 meter, which is the magnitude value here, multiplied by the cosine 0. Of course, we know that if I make a cosine 0, that means 1, and sine 0, it means 0. So if we apply it in the Cartesian coordinations, if you go to the x-axis, it will give you only direction to the x-axis and the right side, to the positive number. There is no direction to the y side or to the z side, if you want to mention it. Type the speed. It is the rate of distance changed by the time. How much distance is happened or is applied per unit of time. If we add a direction to it, it becomes as velocity. So velocity is the speed with direction. Example, if I say 1 meter per second, that means speed. But if I add a direction to it, it means 1 meter per second, and I give the direction right. That means I can say 1 meter second in the right side, or can say in the positive number of x-axis. If you say that in a Cartesian coordination. Cartesian يعني شباب معناته هو ايش؟ الإحداثيات السينية والصادية والعينية. X, Y, Z. Azimuth, longitude, altitude. طيب. We can express it as 1 meter per second. All of them is magnitude as absolute value multiply the cosine 0, because I mentioned what? Right. That means in the positive side of the x-axis. And we know that cosine 0 is 1 and the sine 0 is 0. That means only one direction in x-axis. طيب acceleration, it is the rate of speed or velocity changed by the time. Distance changed by the time is speed. Then again the same speed, if it is changed by the time, it's give me an acceleration. So the time here is calculated 2 times in the denominator, see here, square. So it is a scalar acceleration. If I say that 1 meter per second square, if I say 1 meter per second square in the left side, that means a vector acceleration, and we can express it as 1 meter per second square, all of them absolute value, which is the magnitude, multiply the cosine 180 degrees. Notice here I mentioned 100 degrees, that means in the x-axis, but in the toward the negative values, negative numbers. So in the negative side of the x-axis, and also only happened in the along the x-axis itself, the original axis. There is no y coordination, there is no z coordination here. Now we mentioned this acceleration, distance, velocity. Now we'll go to the mass, which is expressed as the amount of matter in object. Amount of matter in object. It is related to molecules of the matter, يا شباب. It is scalar amount. Scalar. Cannot be becomes a vector. So if I say object has a mass equal 1 kilogram, which means the amount of matter of this object is 1 kilogram. نحن نتكلم عن كمية يا شباب، كمية المادة. كم أي مادة عندنا في الحياة، أي شيء، أي كائن في الحياة، كم المادة الموجودة جوته، كم عددها، كم كميتها. هذه هي يا شباب الماس، كيلوغرام. Because here mass, if you mention mass, many people they confuse between the mass and the weight. الوزن، كتلة والوزن. In order to distinguish between them, let us talk about the force first. As per the Newton's second law of motion, force is a product of mass and acceleration. ضرب التسارع والكتلة، هذا القوة. It is a vector amount, but we can take the magnitude only sometimes. Object has force 50 Newton, and we don't mention the direction, just we take the magnitude value only. That means its acceleration, it has acts as acceleration multiply in its mass, and the result is becomes 50 Newton, and this is the unit of the force. Now let's go to the weight. It is a special case of the force, which is the force exerted by the earth acceleration gravity. So it is related to the gravity of the earth, which means the direction always be downside. If object has weight equal 1 Newton, weight, I didn't mention as a force, I mentioned it as weight, that means immediately the acceleration is the gravity, which is 9.81 meter per second square. That means almost equal 0.102 kilogram exerted by the gravity acceleration, multiply by these values, it gives me 1 Newton. I can express it in other mathematical, I can express it in mathematical way as 0.102 kilogram multiplied by 9.81 meter per second square, all of them absolute value as a magnitude, multiplied by the cosine 270 degree. So this multiplication to give me 1 Newton, multiply cosine 270 degree. Of course, if I apply it, it becomes -1. So the direction here is in y-axis, but in the negative sides, the negative side of y-axis. There is no x-axis here. X-axis is almost 0 here, as the original, and there is no z-axis here, only just to the ground immediately. Right. Now let's start يا شباب talk about the fluids. Fluids are substances, but they are deformed under any shear stress regarding how much this stress is small. and they will take the shape of their container. So I can say موائع. fluids يعني موائع يا شباب. مائع، مادة مائعة تتحرك بشكل متغير، قابلة للتغيير، قابلة للتشكل، تأخذ شكل الوعاء الذي توضع فيه. أي عملية ضغط أو عملية كبس بسيطة أو شيء على طول يأثر على السطح ويأثر على البروفايل. So the profile shape شكل الحركة أو النمط الذي تمشي فيه الفلوت يختلف بناء على اختلاف الضغط والكبس أو الشد أو الجهد المبذول عليها. طيب there are properties they call it specific properties، الخصائص الخاصة بالمادة. So these specific properties are related to the element types of the substance، يعتمد على نوعية العناصر الموجودة في المادة. In general there are basic properties for substances like regarding the status. حتى المواد الصلبة نفس الشيء يعني، ليست فقط للفلويد يعني شباب، ليست الموائع. Even for the solid, not only just for liquid and gases or fluids, it is also included fluids with the solids. We know these properties. I think most of us we know these. Just go quickly for them. Density, and we can say a specific mass. This is another name for density على فكرة يا شباب. Density or specific mass. Sometimes it's called mass density. Specific volume and specific weight. Sometimes it's called weight density and specific gravity. Now I will show you يا شباب a video. I take it from the YouTube. I think it is helpful for us to understand the meaning of these four contents. It gives you the definitions and also the equation in summarized way. I think it's good, and listen to it now شباب.
Welcome. In this video, let us see the properties of fluids: density, specific weight, specific volume, and specific gravity. So let us see the first one, density. Density is actually the mass by volume. So it is also known as mass density and specific mass. And in general sense, it is a measure of mass of fluid occupying 1 cubic meter of space. I will show you one cube here, which is having 1 meter length, 1 meter width, and 1 meter height. It is a cubic meter. So we are measuring how much mass of the fluid can be laid in it. So this is mass of the fluid in it by its volume. Technically it is defined as mass of the fluid per unit volume, and it is denoted by the Greek letter rho. And mathematically we can write it as rho is equal to mass of fluid by volume of fluid, m by v. And the units are kg per meter cube. And if you see the diagram here, so I have given you two cubes here. One cube is having the substance which is having loosely packed molecules. It is another substance which is having closely packed molecules. So you can say very well it is very denser than this. And the most important thing you have to remember is the density of water, which is 1000 kg per meter cube or 1 gram per cc. Please remember that the value is very important. And let us see the applications of density. Where can we see this? Oil floats on water because it is of less dense than water. And take some bowl of water and pour some oil in it. Oil will definitely float, right? Because the oil is less dense than water. And if you see this fluid tower, this is the tower of fluids having different densities. So last one is honey because it is a more denser. On that corn syrup, which is lesser denser than honey, and all the fluids are in descending order of their densities. Honey, if you compare, it is having lot of density compared to the ping pong ball, which is having lesser density. And boating is possible because it floats on the water. This is because boat is less denser than water. And now your work is to find out some more examples. And density of some more important materials I am giving to you: water 1000 kg per meter cube, cement 1440 kg per meter cube. So here I am giving you the important building materials densities, and dry sand, steel, brick, mercury. And now your duty is to search some density of some more materials. So second property is specific weight, so which is denoted by small w, and it is also known as weight density, and is a measure of weight of substance which occupies 1 cubic meter of space. So technically it is a weight by volume. So it is denoted by small w, that is equal to weight by fluid by volume of fluid. And weight we can call it as mass into acceleration due to gravity. W is equal to mg. So we can now write it as small w is capital W by V is equal to mg by V. M by V, that is the density previously we have discussed. So we can substitute it here, rho g. And the units are Newton per meter cube. And what are the uses of specific weight in fluid mechanics? So fluid mechanics, specific weight represents the force exerted by the gravity on a unit volume of fluid. So mass is a constant, it will not change anywhere, but weight will change according to the planet. Our earth planet is having some gravity and its acceleration is 9.81 meter per second. So we are measuring the mass by virtue of gravity. Mass which is in the influence of gravity, that is actually weight, and we call it as even force. So that is why we are representing it as Newton per meter cube. So let us see the third one, a specific volume. It is reversed to the density. So it is volume by mass. To say mathematically, that is volume by mass. It is actually the property of material which is defined as number of cubic meters occupied by 1 kilogram of particular substance. 1 kg is occupying how much volume? That is a measure. So volume of fluid by mass of the fluid, V by M. This is the reciprocal of density. That is 1 by rho. And the units are meter cube per kg. Reverse to density. So fourth one, last one, specific gravity. And specific gravity, it is denoted by capital S, and it is the ratio of density of that substance to the density of reference substance. So mathematically we can write it as density of fluid by density of reference fluid, rho fluid by rho reference fluid. And reference fluid is here for liquids water and gases air. And we know that very well, liquids and gases both together are called as fluids. It is a dimensionless quantity because it is the ratio of two fluids, right? So it is the ratio of densities of fluids. So rho fluid by rho reference liquid. So if we talk about density of liquids, specific gravity of liquids, that is the ratio of density of liquids to the density of water, rho liquid by rho water. Density of water is 1000 kg per meter cube. I repeat it again, please remember. Specific gravity of water is 1, because when we talk about specific gravity of water, we have to put that density of liquid is density of water by reference liquid is also water. So density of water by density of water, that is 1, and the units will be cancelled out. The unit, this is the dimensionless quantity, and here it is the density. Please check the spelling. And what are the applications of specific gravity? And it is just a measure that shows us how much a liquid is denser or more denser or less denser than water. For example, if specific gravity is more than 1, so we can say that is more denser than water. And for example, any liquid is having less denser, specific gravity less than 1, we can say it is lesser denser than water and it floats on water. For example, you can think of a plastic ball floating on the water. See here. It's a ball floating on the water because ball is having less specific gravity or less denser than water, so it is flowing on it. So you can think of a iron ball in the same place. What will happen? It will sink, right? Because iron ball is more denser than water. So specific gravity of some important materials here. Water is 1, mercury is 13.6, steel, cast iron, aluminium, gold I have given to you. And now your duty is to collect some more specific gravity values of some more materials. And let us see a problem now. So question is to calculate the density, specific weight and weight of 1 liter of petrol of specific gravity 0.7. So what they have given us? Initially they said 1 liter of petrol. So they have given volume 1 liter, that is 1000 centimeter cube. We can convert into meter cube. So because 1 centimeter is 1 by 100 meter, so that is whole cube, we will get it as 1 by 1000 meter cube. Specific gravity they have given us as 0.7. So actually specific gravity volume is rho liquid by rho water, and rho water is, whether they have given or not, that is 1000 kg per meter cube. Rho petrol, so if we substitute that, rho petrol by 100, that is equal to 0.7 specific gravity. So rho petrol we can get it as 0.7 into 700, 1000, that is 700 kg per meter cube. So density of petrol, we got it as 700 kg per meter cube. So first one we got it. So second one we have to find out specific weight. After that we have to find out the weight. See that specific weight. Small w we need to find out. First write the formula. That is small w is weight by volume. But we don't have weight. So let us check. W is also known as mg. So m by v is also known as rho g. So initially we have found out the density. Here the 700 kg per meter cube. Let us substitute it here. So W is equal to rho petrol into G, 700 into 9.81. That is 6867 Newton per meter cube. And the weight we need to find out. Again write the formula for weight density, which is small w is equal to weight of fluid by volume of fluid. And W is equal to, we can write as, if we want weight, weight is equal to volume into weight density. See, weight density we have just calculated it. Just substitute, very easy. So you'll get 6.867 Newton. Volume is 1 by 1000 meter cube.
Fluids used in mechanical systems come in many different types. The type of fluid chosen for a particular application depends on its characteristics. One of the most important characteristics of a fluid is its viscosity. Viscosity is defined as a fluid's resistance to flow. Fluids with low viscosity flow very easily. Water is a type of fluid with low viscosity. Fluids with high viscosity are more resistant to flow. Honey is a type of fluid with a high viscosity. Therefore, honey is more viscous than water. Another characteristic of fluids is the viscosity index. This rating relates the flow of a fluid with its temperature. Many fluids begin to flow more easily as temperature increases. The viscosity index is the measurement of this characteristic. A high viscosity index indicates a small oil viscosity change with temperature. A low viscosity index indicates a large oil viscosity change with temperature. Compressibility is another characteristic of fluids. It measures the change in volume of a fluid as a response to a change in pressure. Fluids, such as gases, are highly compressible. Their volumes change significantly when placed under pressure. Liquid fluids also have a compressibility factor. Water and petroleum-based hydraulic fluid are almost completely incompressible. They don't compress when put under pressure. This characteristic is what allows them to be used to transmit power in fluid systems. Years ago, water was used as the first hydraulic fluid because there was no other liquid available in such large quantities at such a low cost. There are some major drawbacks to using water as a working fluid. Due to its low viscosity, it is difficult to pump. Additionally, the speed at which it flows through the system causes an effect known as wire drawing. Wire drawing occurs when the water flow erodes or scores a pathway in the metal of machinery as it goes around corners and through orifices. It also has corrosive effects on metal machinery. Over time, petroleum-based hydraulic fluids have become much more cost-effective. For starters, it has a lower specific gravity than any other liquid and can be pumped with less power loss. It also lubricates as it works through the system and has little corrosive effects on metal machinery. Flammability is an issue, but with the development of synthetic oils, alternatives to water remain the preferred working fluid. Several factors should be considered when designing a fluid system that uses a petroleum-based hydraulic fluid. The first is cleanliness. Oil never wears out, but it can become so contaminated that it is unfit for further use. Fluid systems frequently employ filters throughout the system to help reduce contaminants. They may also require complete fluid replacement after certain time intervals, and this can become cost prohibitive with larger systems. Another factor common to hydraulic fluids are the use of additives. Additives can be used to reduce aeration and the production of bubbles as the fluid travels rapidly throughout the system. They can be used to administer corrosion inhibitors within the reservoir, and they can be used as a demulsifying agent, which helps the fluid resist mixing with water. The choice of modern fluids is so wide that when designing a new system, fluid characteristics such as viscosity, viscosity index, cleanliness, filtration, and additives should be considered as early as possible in the design process.
Okay, at the end of this video, we should at least understand some of the basics properties of the fluids. And we already run through some concept of physics. Already we know what already previously, but here just we run through them quickly, just to refresh our mind regarding this terminology. Maybe they will come, and for sure most of these terminology will be utilized in the coming weeks. Now, in the coming videos, we will talk in more detail regarding the density measurements and the method of measuring the density, because if we understand the density and the specific weight more deep, we can understand more deep about humidity, which is the next subject after that. And these both subjects, with the help of understanding the viscosity, and maybe also we can utilize them to understand other coming sensors used in the coming process instrumentation, technology, and measurements. Thank you for listening, Shaban, and waiting me for the coming video. Assalamu alaikum.